So going over the limiting and excess reactant problems from last week. Number 1. If 1.72 moles of zinc sulfide is heated in the presence of 3.04 moles of oxygen, which is the limiting reactant and which is the excess reactant? Okay, so for these type of problem, they're asking me for the limiting reactant. So which of these two reactants is going to be used up first? And it's also asking me for the excess reactant, which is which of these two reactants I'm gonna have left over. Remember, the limiting reactant is the one that produces the least amount of product. Okay, so what I'm gonna do is I'm gonna do stoichiometry for starting with both of these reactants. I'm gonna pick one of the product. It doesn't matter which one I pick, but I'm gonna pick one, and I'm gonna solve for that one. So I'm gonna see how much product each reactant makes. In this case, I'm gonna go for this guy, zinc 2 oxide. So I'm gonna see how much zinc 2 sulfide, how much product that produces. Then I'm gonna check how much oxygen, how much that produces. Okay, so I'm gonna start with zinc 2 sulfide. So I have 1.72 moles of zinc sulfide, and I'm gonna do stoichiometry. Okay, since I'm already in moles, my next step is going to be to use the mole ratio. So I have 2 moles of zinc 2 sulfide for every 2 moles of zinc 2 oxide. Like this, moles of zinc sulfide cancel out. I could go to grams, but in this case, since they're just asking me about the limiting and the excess reactant, I'm just gonna stop in moles. Okay, in the next section, when we do percent yield, you're gonna see that you're gonna have to do the next step and go to grams. Okay, but right now I could stop in moles. So what I'm gonna do is I'm gonna get 172 multiplied by 2 and divided by 2, and that gives me 1.72 moles of zinc oxide. Okay, and that comes from zinc sulfide. So zinc 2 sulfide can produce 1.72 moles of zinc 2 oxide. Now I'm gonna do the same thing, but now looking at oxygen. So how much product can 3.04 moles of oxygen make? Okay, since I'm already in moles, my next step is to look at the mole ratio. And according to the mole ratio, there's 3 moles of O2 for every 2 moles of the product. The key in these type of problems is that I need to solve both reactants for the same product. So I need to pick one product and solve for it. Okay, so now I'm gonna do 3.02, multiply that by 2, divided by 3, and that gives me 2.026 moles of zinc 2 oxide. And this comes from oxygen. Okay, so my question is asking me which one is a limiting reactant. Well, which reactant produces the least amount of product? Zinc 2 sulfide produced 1.72 moles of my product. Oxygen produced 2.026 moles. Since zinc 2 sulfide produced the least amount, that means that SNS is the limiting reactant. Okay, and since oxygen, I'm gonna produce so much, that means that oxygen is the excess reactant. Okay, so limiting reactant, zinc was the limiting reactant, Oxygen was the excess reactant. Number 2 says, which reactant is the limiting reactant? So again, they're asking me for limiting. If 0.2 moles of aluminum, so 0.32 moles of aluminum and 0.26 moles of oxygen are available. Okay, so I have to do the same thing. Here I only have one product, so I need to turn both of these amounts of reactants into my products by doing stoichiometry problem, looking at one reactant at a time. So I'm going to start with aluminum. Okay, aluminum, I had 0.32 moles of aluminum. Since I'm already in moles, now I could use my mole ratio, which according to my equation, I have 4 moles of aluminum for every 2 moles of my product. Okay, like this, moles of aluminum get canceled out. I am left in moles of my product. I could stop here. I could take it to grams and see how many grams I produce. But since the question is just asking about limiting, I'm going to stop here in moles. Okay, so what I'm going to do is I'm going to get my calculator. Do 0.32 times 2 divided by 4. And that gives me 0.16 moles of Al2O3, and this came from aluminum. Okay, now I'm going to do the same thing with my other reactant, oxygen. So now I'm going to look at oxygen. Oxygen, I started with 0.26 moles of oxygen. Since I'm already in moles, my next step is going to be to use the mole ratio, which according to the equation is 3 moles of oxygen for every 2 moles of the product. Okay, like this, moles of oxygen get canceled out. I'm left in moles of the product. So I'm going to get my calculator, put 0.26 times 2 divided by 3, and it gives me 0.17 moles of Al2O3. Okay, it's really close, and this came from oxygen. It's really close, but which one produced the least amount? Even though it's just a hair tiny, this one, aluminum, produced the least. So therefore, aluminum is the limiting reactant. Okay, and that is my final answer. That's it. So aluminum is the limiting reactant because it's a reactant that produces the least amount of product. Number 3 says, which reactant is the limiting? So again, they're asking us for the limiting, the reactant that produces the least amount of product. If 3.17 grams of aluminum and 2.55 grams of oxygen are available. Okay, so I'm going to do the same thing that I've been doing, starting with one of the reactants. So I'm going to start with aluminum. Okay, and aluminum, I start with 3.17 grams of aluminum. Now, in this case, it's a little bit different because we're starting with aluminum instead of moles. Remember that in stoichiometry problem, which is just what it is, because we're converting from one thing in an equation to something else. Okay, so we're going from one compound to another compound. So we're doing stoichiometry. Since we're in grams right now, grams of aluminum, the first thing we need to do is go from grams of aluminum to moles of aluminum by using the molar mass of aluminum. Okay, and since it's just Al, we're just going to look at the periodic table for aluminum, which has a mass of 26.98. So in the bottom, we're going to put 26.98 grams of aluminum for every 1 mole of aluminum. Okay, like this, the grams get canceled out, and now I'm left in moles of aluminum. Now that I'm in moles, now I could use my mole ratio. So according to my balance equation, I have 4 moles of aluminum for every 2 moles of Al2O3. Okay, here my moles cancel out. My moles of aluminum cancel out, leaving me moles of the product. Again, I am going to stop here because the question is just asking me for the limiting. In the next section, you're going to see, again, that you're going to have to do an extra step and go to grams. But I'm going to stop here. So what I'm going to do now is I'm going to get my calculator, put 3.17 divided by 26.88 times 2 divided by 4. And that gives me 0.0574 moles of Al2O3. And this came from aluminum. Okay, now I'm going to do the same thing with oxygen. So looking at oxygen now, I started with 2.55 grams of oxygen. I need to turn that grams into moles by using the molar mass of O2. So since I have 2 oxygens, remember each oxygen has a mass of 16 times 2, that is 32 grams of oxygen for every 1 mole of oxygen. The grams get canceled out. Remember that this step right here, that's my molar mass. Guys, let me write it. Molar mass of aluminum, molar mass of O2. Okay. Now that I'm in moles of oxygen, now I could use a mole ratio. Mole ratio, mole ratio. Which according to the equation, I have 3 moles of oxygen for every 2 moles of Al2O3, aluminum oxide. Like this, the moles of oxygen get canceled out. So now what I'm going to do is I'm going to get my calculator, do 2.55 divided by 32 times 2 divided by 3, and it gives me 0.0531 mole of Al2O3, and this came from oxygen. Okay, so which of these 2 reactants, aluminum or oxygen, produce the least amount of product? Oxygen produced the least amount, right? Oxygen was only able to produce 0.53. Aluminum produced a little bit more. So that means that oxygen is the limiting reactant. Okay, I am done. That's my final answer. Number 4 says, if you place 0.092 moles of iron, so 0.092 moles of iron in a solution containing 0.158 moles of copper 2 sulfate, what is a limiting reactant? Okay, so it's asking me for the limiting reactant. Which of these 2 reactants will produce the least amount of product? Okay, so again, I'm going to choose one of the product. It doesn't matter which one I choose, my answer will be the same. So just for the sake of writing less, I'm going to go for copper. Okay, I'm going to solve both reactants. I'm going to figure out how much copper I can produce. Again, it doesn't matter which one I choose. My answer will still be the same. My limiting reactant will still be the same. Okay, so I'm going to start with copper 2 sulfate, and I have 0.158 moles of CuSO4. Okay, now this question is I'm already in moles. So if I'm already in moles, my next step is going to be to use the mole ratio. Okay, and according to my balanced chemical equation, I have 3 moles of CuSO4 for every 3 moles of my product. 3 moles of Cu. Okay, if I would have chosen to solve for this, then would have been 1 mole up here of Fe2SO4 3. Okay, but I chose copper. It doesn't matter. My final answer will still be the same. Okay, so most of CuSO4 get canceled out. I'm going to stop here. So now what I'm going to do is I'm going to multiply 0.158 times 3 divided by 3. And it gives me 0.158 moles of copper. And this comes from, who did it come from? CuSO4. Okay, now I'm going to do the same thing for my other reactant, which is iron, Fe. So Fe, I started with 0.092 moles of iron. Since I'm already in moles, my next step is to use a mole ratio, which according to my balance equation, I have 2 moles of iron for every 3 moles of copper. Okay, like this, the moles of iron get canceled out. So now what I'm going to do is I'm going to get my calculator, multiply 0.092 times 3, divide that by 2, and I get 0.138 moles of copper. And that came from iron. So which reactant, iron or CuSO4, which of the two produce the least amount of product? Iron. You see how iron produce only 0.13. Copper 2 sulfate produce 0.15. So iron produce the least amount of product. Therefore, that iron, Fe, is the limiting reactant. And that is my final answer, that iron is the limiting reactant. That means that CuSO4 will be in excess. I'm going to have leftover. I'm going to have extra copper sulfate. Okay? Fe, I'm going to completely use it up and make this much product. Once I make this much product, I don't have any more iron, but I am going to have CuSO4 left over. Okay? Because that will be my excess reactant. That means that I have extra of it. Now to do number 5. It says, which is the excess reactant? So now this one's asking me for the excess reactant. Remember that excess is the one that produces the most amount of product, not the least. So which is the excess reactant when 560 grams of magnesium iodine, so 560 grams, and 360 grams of bromine react. Okay, so again, I'm going to choose one of the products. It does not matter which one I choose. My answer is not going to change. But in this case, I'm going to choose to solve for magnesium bromide. Okay, it doesn't matter which one I choose. I'm just going to choose that one. So I'm going to turn both reactants into the same product to see how much of each I produce. So starting with MgI2. Okay, I have 560 grams of magnesium iodine. Now, since I am in grams, okay, my first step is what? I cannot use a mole ratio yet because I'm not in moles. I'm in grams, so that means that I need to use the molar mass in order to go from grams to moles. So I need to find the molar mass of MgI2. So I'm going to take the mass of 1 magnesium, which is 24, you can see it, 24.31, plus the mass of 2 iodine, which is 196.90. Add both of these together, and it's going to give me 200 278.11 grams of MgI2 for every 1 mole of magnesium iodine. Like this, the grams goes away. Okay, now I'm in moles. Now that I'm in moles, I could use the mole ratio. Okay, you guys should know how to find the molar mass. I didn't work it out, but I explained. So now my mole ratio, since I don't have a number in front of this, that means that I have 1 mole of MgI2 for every 1 mole of my product. Like this, the moles of magnesium iodine get canceled out, and I'm left in moles of magnesium bromide, my product. Okay, and I'm gonna stop here. So now what I'm gonna do, I'm gonna get my calculator, get 560 divided by 278.11 times 1 divided by 1, and it gives me 2.0135 moles of MgBr2. And this is from my reactant magnesium iodine. Okay, now I'm gonna do the same thing, but looking at bromine. So starting with bromine, I have 360 grams of Br2. Okay, since I am in grams, I cannot do the mole ratio yet. I first need to convert that into grams by using the molar mass of 2 bromines. So I'm gonna get the mass of 1 bromine, which is 79.90, multiply by 2 because I have 2 of them, and it gives me 159.8 grams of bromine for every 1 mole of bromine. Like this, the gram get cancelled out, and now I'm left in moles. Now that I'm in moles, now I could use my mole ratio. According to my equation, I have 1 mole of Br for every 1 mole of my product. MgBr2. Okay, the moles of bromine get cancelled out. I am left in moles of the product. So now what I'm going to do in my calculator is I'm going to do 360 divided by 159.8 times 1 divided by 1 gives me 2.252 mole of MgBr2. And this comes from bromine. So this question is asking me for the excess reactant. I remember that the excess reactant is the reactant that produces more product. Okay, limiting produces the least amount of product. Excess produces the most amount of product. So which of these 2 reactants produces more product? Bromine. Therefore, Br2 is the excess reactant. Okay, that means that once I produce this much product, that's it. I cannot produce any more. Okay, so I'm gonna have leftover bromine because I cannot produce how much bromine is telling me because I'm not gonna have enough of this other reactant, the limiting one. So Br2 is my excess reactant. That's my final answer. Now the last problem, number 6. If you have 22.9 grams of nickel and 112 grams of silver nitrate, so 112 grams of silver nitrate and 22.9 grams of nickel, which reactant is in excess? Okay, so again, this question is asking us about which one is in excess. Okay, so which of these 2 products is going to produce the more product? Okay, which is going to have leftover. So I'm going to pick one of the reactants. It doesn't matter. Sorry, one of the products. It doesn't matter which one I choose. My final answer will be the same. I'm just going to choose silver here. So I'm going to do stoichiometry and solve both reactants for the same product. Starting with AgNO3. Okay, so I have 112 grams of silver nitrate. Since I am in grams and not in moles, remember that my first step is going to be to do the molar mass for AgNO3. Okay, I'll do it here. So AgNO3. Okay, so silver. If I look at the periodic table for silver, its mass is 107.87. Nitrogen, I have 1. It is 14.01. And oxygen, I have 3 oxygen. Each oxygen is 16 times 3. That is 48.00. I add all of them, and it gives me 169.88 grams per mole. Okay, so I'm going to put the number down here. 169.88 grams of AgNO3 for every 1 mole of silver nitrate. Like this, the grams get canceled out. Now that I'm in moles, now I could go and look at my balance equation to look at the mole ratio. So according to the mole ratio, I have 2 moles of AgNO3 for every 2 moles of my product. For every 2 mole of Ag. Again, the moles of my reactant get canceled out. So now what I'm going to do in my calculator is get 112. Okay, let's do it together. I'm going to get my calculator. I'm going to do 112. Anything at the bottom, I'm going to divide. So divided by 169.88 times 2 divided by 2. I don't really have to do that because that will give me a 1. So enter. And it gives me 0.6592 moles of silver. And let me just make sure I did it right. Divided by 169.88. I did. Okay. Now I'm going to do the same thing but looking at my other reactant, which is nickel. So looking at Ni. I started with 22.9 grams of nickel. Okay, now I'm going to do stoichiometry to solve for the same product, silver. Since I am in grams of nickel, I need to use a molar mass of 1 nickel, which nickel is right here, somewhere in the periodic table. And the mass is 58.69. So I'm going to divide by 58.69. Okay, remember this is the molar mass of nickel. Grams of nickel for every 1 mole of nickel. Okay, now that I am in moles, because the grams get canceled out, now I could use a mole ratio. And according to my equation, there's no number in front of nickel. That means that I have 1 mole of nickel for every 2 moles of silver. The moles of nickel get canceled out. Now I'm left in moles of silver. Okay, so now I'm going to get my calculator. I'm going to get 22.9 divided by 58.9, since the 2 is on the top, times 2. And that gives me 0.7775 moles, 6 moles of Ag. Okay, so this came from nickel, from Ni, and this came from AgNO3. So this question originally asked me for the excess reactant. Excess reactant, remember, that is a reactant that produces the more product. So which one produces more product? Nickel. Therefore, Ni is the excess reactant. Okay, excess reactant. That is my final answer. Nickel is my excess reactant. AgNO3 will be my limiting reactant because it produces the least amount of product.